Okay, here's our next three postulates to prove triangles congruent. You still have to get three congruent parts, but it's on what parts they are. The next postulate that says you'll make congruent triangles is called the angle-side-angle postulate. How are we going to abbreviate that thing? ASA. And it says if two angles and this is what's important, the included side. And I'll talk about included sides when I get to the picture. Are congruent to the same parts in another triangle, then the triangles are congruent triangles. They're the same triangle. So what we need are two angles. So let's say I pick this angle congruent to this angle, and this one to this one. What it means by included side, it's the side in between those two angles. So if I think of this as a vertex, and this as the other vertex, it's this side that I would need. So it's angle, side, angle. You can tap it out. The side is right in between the two angles. So I need this side here. Now these are the two that people confuse. This next one is called angle, angle, side triangle congruence postulate, which we will abbreviate AAS. So this one also has two angles and a side. So did this one up here, two angles and a side. It's the position of the side that makes it different. This is the only one that's not symmetrical. When you read it backwards, you can have SAA. So I would take that as another name for this one, just reading it from the backwards. Side, angle, angle. Okay? So it starts out the same. If two angles and an opposite side are congruent to the same parts in another triangle, then the triangles are congruent. So let's go with the same two angles that I had up above. So included side meant in between the two angles. Opposite means if I'm standing on this angle, what side is opposite from me? Opposite means across, it would be this side and this side. Or if I'm standing on the double angle, what's opposite from me there? From the bottom. So it can be either of these two sides. You got to be across from one of them. I'm going to pick the bottom one. So what makes these two postulates different from each other is where the side is in relation to the two angles. If it's in between the two angles, it's angle, side, angle. If it's across from, it's angle, angle, side. Or side, angle, angle. See the difference between the two? Okay. The third one only works for right triangles. The other four, the two from yesterday and these two here, work for any kind of triangle. This one's special. It only works for right triangles. It's called the hypotenuse leg right triangle congruence postulate, which we will abbreviate HL, and we're going to have another abbreviation for it in a second here. It's still getting three parts. You got to get the right angle, and then the hypotenuse and the leg. So if the hypotenuse and one leg of a right triangle are congruent to the same parts in another, then the triangles are congruent. So I have to get the right angles to make them right triangles. Where's the hypotenuse in a right triangle? Across from the 90. And then I need one of the legs, and it doesn't matter which one. Well, if I think about this in terms of angles and sides using A's and S's, what do I actually have here? I've got an angle, a side, and a side. How would you abbreviate angle, side, side?
AAS.
Angle, side, side. Oh, ASS. That doesn't really work for us.
SSA.
SSA could work, but we're even going to get away from that. We're going to, instead of angle, side, side, what does this angle really have to be, though?
I'm putting that one down for ASS.
It has to be a right angle. It can't just be any angle like all the rest. We're going to go RAS.
I like rats.
We're going to go RAS. If you choose to use angle, side, side, it will not be marked correct.
What?
Right angle, side, side works, because it only works if it's a right angle. If this was not a right angle, this would not work for us at all. So it's a special case only for right triangles. These other ones work for any kind of angles. It doesn't matter. So, hypotenuse leg or RAS, your choice. The book doesn't use RAS. I made this up. I like it. That'll work too. So, that anything with the hypotenuse leg or RAS. I will not accept ASS
Why
ever.
can't you say it?
I could, but I don't want
Mr.
to.
Young was saying that.
God, you like, I'm recording for God's sake. It'll probably make me lose my job. Anyway, okay, here we go.
My voice is on there.
Yeah.
Yeah. I said it.
Hello?
Okay, there's our two triangles. Let's go A,
S,
B,
S,
C,
D.
D. I am going to give you this and this, this and this. You are going to decide if the triangles are congruent. On homework, you really just have to look in there and find the third part. For notes, I'm going to make us talk through them like we're doing a proof because it's just good practice. So, I can see in the picture that angle A is congruent to angle C because it was given to me with the arc mark. I'll put a little 1 and 2 at B because I can't use angle B because there's too many angles there. I've got angle 1 congruent to angle 2. That was given to me with arc marks. Where's the third congruent part at?
BD.
BD to BD. Very good. They share that side BD right there. BD is congruent to BD, and that is the reflexive property.
I got this.
You got this. So are the triangles congruent?
Yep.
Let's go. If I name the first one ADB, what order do you have to put the second one in? CDB. Which postulate now says that those two triangles are congruent? What three parts did we get? So cover up one. I've got an angle, I've got a side, and I've got an angle. What position is that side in? You've got an option. You got angle, side, angle, or you got angle, angle, side?
Angle side.
Is it angle, side, angle? Why is it not angle, side, angle? Yep, to be angle, side, angle, if I touch the two angles, I've got to connect them for the side. The side would have to be in between those two, and it's not. It's across from this one. So that makes it angle, angle, side, where the side is across from one of the angles, not in between. These are the two that people get confused. Alright, this one. Let's go with a parallel top and bottom, a parallel left and right, and that's it. And we'll go A, B, C, D. Okay, I didn't give you anything congruent, but when you see a set of parallel lines, you should be able to get alternate interior angles. 99% of the time, that's what you're going to get. I've got two sets of parallel lines, so I should be able to get two sets of alternate interior angles. So let's go with the top and bottom parallel. If the top and bottom are parallel, and this is my transversal, where are my alternate interior angles at? I know they're at B and D. Is it at the top or bottom of B? Top of B. Because you got to touch the parallel line in the transversal. So then that means where at D? Bottom at D. So I'll put a 1 and a 2 there. Now let me go with the left and right being parallel. So these are my parallel lines now. This is my transversal. Where are the alternate interior angles for those three lines? Not angle A. That's not my transversal. That's not even in play. That line is gone, and so is this bottom line.
Top of angle D.
Top of angle D and bottom at B. So with each pair of parallel lines, you should be able to get a pair of alternate interior angles. So, angle 1 is congruent to angle 2 by AIAC. That was the top and bottom parallel. And then angle 3 is congruent to 4, also by AIAC, because the left and right were parallel. Where's the third congruent part at? That common side here, they both share BD. So I've got my 3 parts, so that means triangle, I'm going to go DAB, DAB. Match that one. It is BCD. If I start at D, that's in this top triangle, that's the double arc mark, so I got to go with the double arc mark here. It'll be BCD. Now, what 3 parts did we get? Cover up one of the triangles if it helps. Look in one triangle, I've got an arc mark, a double arc mark, and I've got the tick mark. Okay, is it angle side angle or is it angle angle side? Angle side, because the side is right in between the 2 angles. So it's ASA. Okay. Back side. Okay, same idea. I'm going to give you right angles here. And I'm only going to give you tick marks here. Can you find a third congruent part in that picture? Oh, sorry. Yep. Can you get a third congruent part in that picture? Is there any other markings in there that tell us anything? Sophie, what are you thinking? Why? What's here that's telling you these would be congruent besides looking like they're congruent? No, that doesn't mean that. No. Yeah, those are congruent. These are congruent. Is there anything else? Not until you get me a third part. Nope. We only got one angle.
Was it 2 like inside angles, 2 right angles?
Oh, here, but those are outside of the triangle, so that doesn't really help me. I need stuff in about this triangle and this triangle. I'm going to tell you. Nope. What am I going to tell you?
Why would you do that?
There is not enough info here to get those 2 triangles congruent. So don't think you always can get enough. If they don't give you enough information, they don't give you enough information. There's only 2 congruent parts there. You cannot come up with a third part by looks. Okay. Let's go. This is kind of light, but that's here. I'm going to give you this. I'm going to give you this.
Not enough information.
This and this.
Nope, nothing.
Oh, yeah. There's plenty of information there. I see 2 congruent parts. I see the right angle. And I see these tick marks. Where's the third part at?
That line that they share.
That line that, oh, I didn't put any letters on. Let me put some letters on there. W, X, Y, Z. Alright, so let's go. We had WZ congruent to XY, that was given. I'll put a little 1 and 2 by X and Z. Why is angle 1 congruent to angle 2?
Given.